Good afternoon, I am Mr. S. Thank you for joining me for what will be a fun video over here, learning how to do comparisons of situations and numbers that you see right here before you. Some of these are intuitively easy, some of these you can do on your calculator, and some, such as these, are outside the bounds of your calculator and you couldn't do it, so you would have to come up with a good shortcut and a foolproof technique to manage something like this. Starting here from the very top, 2 exponent 3 and 3 exponent 2, you know this right here is an 8, that right here is a 9, so you know clearly that is larger, so there's no doubt. When you're looking at this 22 exponent 33 and 33 exponent 22, you can bring your calculator and see what would happen. You could possibly do this. You'd have 22 exponent 33, and here you're getting 1.99 exponent 44. And we'll put that right here, 1.99 exponent 44. When you look at the other one, 33 exponent 22, we have 2.55 exponent 33. Now the problem is these are ambiguous because we don't know if the effect of this 44 in terms of an exponent on 1.99 for a base is larger than 2.55. Here you have a larger base, smaller exponent. Here you have a smaller base, larger exponent, but we still cannot comprehend. One way you can get away from this is minus 1 from the other. If you get a positive value, then the one which you minus from would be larger. Like if I were to take this and minus it from here, I ended up with a positive value, then this was certainly larger. If I minus this from here and I ended up with the negative value, then I was minusing or subtracting a larger value from a smaller value. You know what I mean here. So let's do this. We'll do 22 exponent 33 minus 33 exponent 22, and I'm getting here a positive value, so that tells you that this right here is larger, and indeed it will be the case. So that's one technique over there. However, for these questions which are like these right here, where you have triple digits in terms of exponents and bases, or even numbers larger than that, you must develop a technique for which you can bring in your calculator and not exceed its capability, and that technique would be natural logs. Think of something like this: y is equal to a to the power of b, natural log y is equal to b, natural log a. This is what you want to do. It doesn't matter what you have over here. You could even solve for y and say y is equal to e exponent b ln a, but you don't need to. What you can do is this technique right here, this specific step for both items, and then you'd compare b natural log a with the b natural log a of the other side, and that natural log technique would be the one I would certainly recommend for you. Right here, natural log y is equal to 333 natural log 222. That's coming from this side. Here we can use a different letter if you want. Natural log z is equal to 222 natural log 333. Now these are easy because the natural logs of large numbers are generally not very large answers. Look right over here and let's compute this. 222 natural log times 333, I'm getting 1799. And I can compare that. 1799 is equal to natural log y, but we don't need to even solve for that y. Here we'll see what the natural log z is equal to. We just have to do 333 natural log times 222, and I'm getting 1289. And you can now clearly see which one is larger. It was this one right over here. This is larger. 1799 is larger than 1289, and this right here would be the technique I would recommend for any type of questions which are like this, a and really large numbers. And here I'm just keeping it a single base because this base can represent a number of digits or anything which looks like this. These type of questions always bring in the natural log. But now the question which comes in our mind, is this technique actually foolproof, or is this technique actually reliable? And the answer is it is reliable because we can test out this technique to be good. The way you want to test it out is for a known value or a known set of values and see how it will apply over there. 2 cube and 3 squared, let's bring in that technique. Natural log y is equal to 3 natural log 2. Natural log z is equal to 2 natural log 3, and now solve for this, and you know this side will be larger than this side, and it will indeed be the case. Let's look right here. 2 natural log times 3, I'm getting 2.079. 2.079. Now let's look at that side. 2 natural log 3. 3 natural log times 2, I'm getting 2.197, and you see clearly this right here is larger, and it confirms this to be the case. This was right, this was right. So if you're ever asked or challenged with a question like this, bring in the natural logs and then compare your natural log values with either sides. This right here was technically no different than you looking at a function which is y is equal to 222 exponent 333, like a y is equal to b, a horizontal line, a linear line, horizontal, except this value here is so high that you could never even graph it. But by bringing in the natural logs, you're looking at natural log y is equal to 333, natural log 222. You could technically get away with this little bit of a cheat. Imagine you eliminate the natural log. Now you're looking at a y is equal to this. Now this value, everything has been brought down to a much lower line, and this lower line can be compared to another lower line over here, and you can do it. For these type of questions, if you ever get challenged, bring in the natural logs and compare the natural log values of both sides. Always do that, and you know it will be right. This, as I will repeat again, would be 333 natural log 222. Compare this with this 222 natural log 333, which your calculator can easily compute. And that's it for this video. Thank you for watching.